connection. Howdy from West Virginia. Man, still lost. Okay, but we're having fun with this, and what we're going to have fun with is joke of the day, because you know it is the best part of the day. You've been waiting for joke of the day, so let's do this. Did you hear about the two antennas who got married? Well, the wedding was terrible, but the reception was great. Because they had a really good connection. All right, well, let's connect ourselves to percents. What we're going to do here is we're going to take a look at percents and what they are and how to convert from a decimal actually a fraction to a decimal to a percent and vice versa. So let's first look at what percents are. A percent is simply a rate. And we've talked about rates before, that rates can be expressed as fractions. Fractions, we've talked about this before, that they are a part out of a whole. So the key here is that whenever you have a percent, the whole is going to be 100. So you will have a number over 100, and that is your definition of what a percent is. It's simply a number over 100. So let's take a look at the situation that we've got here, where we have 87 over 100. Now, based on what this says, 87 over 100 means that that's going to be 87%. But we've also looked before at this idea of fractions being rational numbers, that we can convert them into decimals. And we said in order to convert it to a decimal, that bar means division, and we said we always divide up. So that's what we're going to do here, is we're going to take this 100, we're going to divide it into that 87, divide up. Now when we take that 100 and we divide it into 87, we know that it won't go into 87, so what we do is we put a decimal point and string a bunch of zeros behind it. So now we do know that 100 will go into 870, and we do know that it'll go in 8 times. And 8 times 100 is 800, which we'll write down here. We'll subtract and get a remainder of 70. Then we know we'll drag down that next 0, and we do know that 100 goes into 700 7 times. And then 7 times 100 is 700, leaving us with that remainder of 0 after we subtract. And we know that the decimal point goes right up here. We know that we put our placeholder 0. And so that tells us that 87 over 100, not only is it 87%, but it is also 0.87, which allows us to discover what it takes to turn a decimal into a percent. As you compare this decimal to this percent, notice they both have the 87. But notice that this one has a decimal point in front of that 8. This one, where is the decimal point? It's there. It doesn't look like it's there. But where is it when it doesn't look like it's there? Absolutely, it sits right here in the back. So then how would you convert from this decimal to this percent? Absolutely. You're going to move this decimal point right here 2 places to the right, bam, bam, and that'll turn it into a percentage. So my rules then for changing a decimal to a percent are: move that decimal point, move the decimal point 2 places to the right. To the right, to the right, 2 places to the right. So then in this example it says change that 0.175 to a percent, and we just discovered that in order to do that, that means I'm going to take that decimal point, I'm going to kick it 2 places to the right. So 1, 2, bam, bam, that gives me 17.5%. Easy enough. So now what if we're going to work backwards? What if we're going to change a percent to a decimal? Well, it stands to reason that if we're working backwards, we would do the reverse of this. And as you can see in the example here, if I'm going to turn this percent into a decimal, that means I'm going to take this decimal point that I see right here, and I'm going to kick it 1, 2 places to the left so that it'll sit right there. And so it does exactly what we thought, and that takes this rule and just reverses it. So instead of moving that decimal point 2 places to the right, when we change from a percent to a decimal, we're going to move that decimal point still 2 places. Notice the similarities here. That makes the memorization, the understanding much easier. 2 places in both cases, but now it's 2 places to the left. So in the example that we have here where it says change that 3.6% to a decimal, we know that we're going to take this and we're going to kick it 2 to the left, 1, 2, bam, bam. It's going to sit right here. Whoa, I've got an open space. What do I do with the open space? We fill in a placeholder 0. So I'm going to have 0.036, and we know that oftentimes we get kind of sloppy with our decimal points and can barely see them. So we put the placeholder 0 out front. That space reminds me, oh yeah, there's a decimal point there. But hey, let's get good with it. Make those decimal points nice and big and clear so we can see them. So we get a 0.036 when we convert from a percent to a decimal. Now, a lot of people say there are entirely too many rules in math and I can't keep them all straight. But notice those similarities that we have here. That helps because, quite frankly, you only need to know one of these rules. Because you know that to do the opposite, you're going to reverse it. So perhaps you're one who says, I'm just going to memorize what it takes to change a decimal to a percent. That when I go from this to this, I'm going to kick it 2 places to the right. And that's all I need to know. Because if I'm doing the reverse and going from a percent to a decimal, I'm going to reverse the rule. And I'm going to kick it 2 places to the left. Or you can memorize this rule and just reverse it if you're going in the other direction. That helps with that memorization, making the processes, number one, easier to understand because you can see where they come from. But number two, makes that memorization, you're cutting it in half and you don't have to memorize as much. So that ought to help, and I hope it does. Have a great day.